So hello to everybody. Good evening. Welcome to January AstroQuest. Welcome to 2023. Happy New Year, everybody. We're going to have a nice program for you tonight. My name is Kevin Kopczynski. I am the STEM curator at the Springfield Science Museum. Joining me today is Caitlin Goulet, who is a member of the Springfield Stars Club. And also we have Jenny Powers, who's director of the Springfield Science Museum, and she's going to be helping out in the chat. So if you have questions about the museum's astronomy, anything, please put them in the chat. And if I don't spot them, Jenny will bring them to my attention. So and if you are a regular attendee, if you've attended in the past, usually we have Rich Sanderson with us. Unfortunately, Rich is under the weather with the flu, so he's out of action tonight. And I'd like to just say a brief mention about the Springfield Stars Club. The Stars is an organization that was started as amateur astronomers, people who were originally interested in making their own telescopes. Nowadays, that's not necessary to be in the club, but people who are just very interested in astronomy and sharing that with each other and with the public. The Stars are part of most of, if not all of, the astronomy programming we do here at the museum, and it really elevates our game in presenting astronomy. So they meet on the fourth Tuesday of every month. Well, I shouldn't say every month, from September to May. They meet on the fourth Tuesday. The January and February meetings will be online. So we'll post Rich's email. So the way to get the links is to email Rich, and he will send out the Zoom link to the meeting. And certainly welcome you to come on by and do that. The meetings are free and open to the public. If you decide to join the Stars Club, there is a small annual dues. Thanks, Jenny, for getting that into the chat for us. I'd like to start out then by introducing Caitlin. Caitlin is a member of the Springfield Stars Club, and despite perhaps her youthful appearance, she is a longtime member of the Springfield Stars Club. And something that we don't mention here too often, but Caitlin also founded an astronomy club out of her school in Westfield. And we had at our Stars Over Springfield the other night, we had a few of them come by and give presentations about their interest in astronomy. It was really a fantastic program. So Caitlin is also author of a newsletter. You can get that newsletter by emailing to starryscoop@gmail.com. That will show up in the chat, I bet. And you will get on the list. And Caitlin, is it going on 3 years for that now?
Oh gosh, it's been a while. It might. It's getting there.
I think so. I think so. So anyway, without further ado, Caitlin, go ahead and take it away and let us know what we can look at out there in the sky.
Awesome. Thank you for that wonderful introduction, Kevin. That the Stars Over Springfield event. I mean, the club was. I'm so proud of those kids. It was so much fun. It was such a great experience. Thank you for that. Welcome again to another AstroQuest, everyone. Tonight, I will be giving you guys the observer scoop. I'll be going over a portion of the sky, and just explaining what you can observe. So like Kevin mentioned, I do write a monthly newsletter called the Starry Scoop. If you would like to receive a copy, you can contact me at my email address, starryscoop@gmail.com, or I'm on Facebook. There's a Facebook page, just Starry Scoop. So tonight, we will be exploring the constellation Orion the Hunter. But what is a constellation first? There are 80 official constellations in the sky. And like I always say, think of them as puzzle pieces. Constellations each take up a specific region, and they have borders, and they all fit together to create the entire celestial sphere. So on the right here, we have a star map of Orion, and this highlighted area is Orion's puzzle piece. This is the official constellation. Now, stargazers and astronomers recognize these constellations with their bright stars creating star patterns. So Orion resembles a hunter in the sky. We have two legs down here, a belt, a sword hanging down, two shoulders, a head, him holding a club high in the air, and a shield. So that's the official star map. Over here to the left, we have what Orion appears as to the eye and the eye under dark skies. And really look at its belt. That's how you're gonna find Orion. Just look for its belt. Just so many bright stars in Orion. Orion is one of the most popular constellations in the entire sky. This is because it lies almost exactly on the celestial equator. So it's visible from all over the world, the northern and the southern hemisphere. So a few hundred years ago, astronomers didn't have these official star maps. So instead, they drew pictures of the constellations, cartoon characters. We can see here Orion holding his club up high, his shield or head of a beast that he slayed. I just thought I'd share some photos with you guys, please. So I won't go too in depth in this because I know Kevin will take you on a tour of the night sky soon. But Orion can also be utilized as a guidepost in our night sky. So if we take his belt stars and we use them to point in this direction, we come across the star Sirius. Sirius is the brightest star in our night sky. Looking to the other direction, they point almost directly to the Taurus constellation. More specifically, the head. It is marked by a V-shaped pattern of stars with the bright red Aldebaran marking the eye. Using the bright stars Rigel and Betelgeuse, they point directly to the Gemini brothers. So Orion is comprised of just so many bright stars, very easily recognizable. The brightest star in Orion is the blue supergiant Rigel, located right here. Its name means the foot in Arabic. It shines a brilliant white-blue color. And that's contrasting with the red supergiant star Betelgeuse, which in Arabic means the armpit. Betelgeuse shines a brilliant red and orange, and it's more than 800 times the size of our sun. If we replaced our star with Betelgeuse, it would completely engulf the entirety of the inner planets. We wouldn't be here. So I also highlighted some double stars in and around the Orion region. Double stars are just some of my favorite objects to observe. With the unaided eye, they appear as a single point of light, but when you magnify them with binoculars or a telescope, two or more stars can be revealed. And when you split those stars, when you're finally able to resolve those two stars after seeing a single point of light, there's just a rush of excitement, like seeing a rainbow or a waterfall. And sometimes the color contrast between these stars is just amazing. You could have a red star with a white star. It's just gorgeous. So there are also many nebulae.
Caitlin, I'm sorry to interrupt you, Caitlin, but I had a question.
Mhm.
So this summer was my first spring, I guess this spring, moving into summer was the first time that I ever had a chance to recognize individual stars and know their names. And I thought that the brightest star in our night sky then was Arcturus. Is that something that changes at different times of year, or was I just misinformed?
Arcturus is definitely a bright star in our sky.
Okay.
It could be up there. Yes, Kevin?
Yeah, it probably depends on exactly when you were watching. Sirius is the brightest star that you can see. That is that at some time during the year. But Sirius is not always visible at every time of the year. So at other times of the year, there is a star that is the brightest one that is sort of available to you to see. And it may have been Arcturus for a while. And then Vega kind of comes in the summertime and is a fairly bright one as well.
Kevin, I knew that Arcturus was the brightest at the time because it was you who told me.
Okay,
And I
then it
trust you.
was, so then it was at that time, but not the overall brightest star in the sky.
So how many times does the brightest star in the sky change during the year?
Never really thought about that.
I do not. It really depends. I do believe that Arcturus is the brightest star in the northern hemisphere. And then Sirius is just the brightest star overall. So
Okay.
you could also be thinking about that as well.
Thank you. Well, thank you anyway for that explanation. I did not realize that the brightest star we could see changed.
So continuing on, we'll be discussing a few more nebulae within this region of the night sky. We'll begin with the famous Orion Nebula. This photograph here, me and my father took a few years ago from our driveway. I'm very proud of this photo. You can kind of see the color contrast within it. Just gorgeous, gorgeous nebula. This object is located right in the sword of Orion. So if you could picture a sword hanging down from its belt, that's where it would be. The Orion Nebula is one of the most studied objects in the nighttime sky. It's one of the brightest and it's one of the closest star forming regions to us. It's even visible with the unaided eye. We have two nebulae here. We have the Horsehead Nebula and the Flame Nebula. So these are located right near the star Alnitak, which is this star in Orion's belt. And in this photograph, this bright star here is Alnitak. So you can really see how close they are to that star. The Horsehead Nebula is another very popular object, not only to look at, but a lot of people like to photograph it in the sky. This is because it's a dark nebula that is sitting right in front of an emission nebula that projects light. And the silhouette resembles a horse's head. So it's just an amazing object. You can see it in this photo, how it resembles kind of a horse. Of course, we also have the Flame Nebula. This is an emission nebula. So that means that the gas and dust within this object has become ionized and it shines with its own light. So this object is a little bit out of the Orion region, but it's definitely a highlight. I couldn't leave it out. This is the Rosette Nebula. A beautiful photo. Thank you to Tim Conley for letting me use this. This is another emission nebula. So the gas and dust has become ionized and it's just projecting its own light. It's shining with its own light. This nebula in the night sky, it spans more than 5 times the area of that of the full moon. So it's huge. And lying right in the center of this is a star cluster called the Rosette Cluster. Definitely a highlight. We also have the Crab Nebula, which is one of my favorite objects, mostly because of its history. This is a supernova remnant. In 1054 AD, astronomers recognized this as a guest star in our sky. It was in the daytime for 23 days and in the nighttime sky for just under 2 years. Eventually, it faded from being able to be observed. But today, when we point our telescopes right here where this arrow is pointing, right in Taurus the Bull, we see the Crab Nebula, and it's just amazing. Lying in the center of it is a pulsar, a neutron star, and it spins about 30.2 times per second. And this is one of the most densest objects in the universe. So this is a very cool object. So before I end off here, I would like to share a few photos of the moon I've recently taken. I was very fortunate enough to be out with my sister a few evenings in like December, early January. We lugged out our 8-inch Dobsonian telescope, which is just easy to use and it's a great instrument. These photos were taken with my handheld iPhone. I just held it up to the eyepiece and snapped photos. I think they came out wonderful. It's amazing what you can do with technology. And I was fortunate enough to get out on 2 days right next to each other. So this is December 28th and December 29th. You can really see the difference. The Terminator is the day-night line on the moon. It can really see how much it changes. I'd really like to look at the 3 clusters of craters near the Sea of Nectar right here. And you can really see how the shadows kind of highlight and amplify all the details of these craters. But when we look at the photo on the right here, here's the Sea of Nectar, and here's the three craters. You can really see how all that detail really left. So it really shows how much the moon can change within 24 hours. Another thing I like to mention is near the Sea of Serenity, you can see some mountain regions being highlighted by the Terminator. And I just think the moon is amazing. It's definitely an object worth seeing, worth observing just with your naked eye, with your binoculars, with a telescope. The moon is truly wonderful. Thank you all for watching. Clear skies, and remember to keep looking up.
Okay, thank you, Caitlin. Had a little trouble unmuting there for a moment. Have you ever gotten the picture of the lunar X again, Caitlin?
Ooh, I know I spoke about it in the Starry Scoop a bit ago. I haven't
Yeah,
gotten an opportunity to see
right,
it
right.
again,
I
though.
and you
I would
got
like
one
to.
picture. You did get a picture of it, I think, at that point.
Mhm.
It is so there's a certain time is she showed you different pictures from different on different days, and the sun rises very slowly on the moon, and it kind of sunrise creeps across the landscape. There's a certain time where the light hits a few ridges in such a way as to make the letter X. It only lasts for a couple of hours. And there's also a V, I believe, as well, and possibly others. The moon it is pretty interesting. There's, so much has happened up there. All those blotches that we see on the moon are a result of either large or small impacts of some kind. There's a lot of geology up there, which sometimes you can see with a backyard telescope, and certainly with thanks to satellites, we see a lot up there as well. So great to and look. We're looking forward at the museum to bring you more about the moon as we bring more imagery from our observatory. We're working on that right now as we speak to be able to do that. This is a program called Stellarium. It is a free program that is available and runs just about on any computer. I believe there's also tablet and phone versions available. I should also mention that if you can dim the lights in the room that you are in viewing this, it will turn out, it'll look a lot better. You'll be able to see things on there a lot more clearly. Stellarium reproduces the view of the sky at any given time and date and on any given place on the earth. And you set those up when you get the program originally. Yeah, you just set up the place. Actually, it will automatically start up at whatever time it is on your computer, and then from there you can adjust as you will see us do. So I think the big news in the night sky, as we're looking here to the west, this is representing about an hour after the sun goes down. Sun's going down about 4:30, maybe a little bit afterwards right now. That Venus is coming back up into the sky. And we're going to be seeing Venus for the spring and into the summer. And we can also see, as it says, it's conveniently, and the other nice thing about Stellarium is it conveniently labels things for you. We can see Saturn is there, and I believe if we can just tweak it a little bit, there is Jupiter up there a lot higher in the sky. And you can kind of see how they seem to fall on almost the same straight line. This is called the ecliptic, and it is the apparent path of the planets and the sun across our sky because we all orbit the sun in just about the same plane. Um, so it varies just a little bit. So everything kind of looks like it's in a straight line there. And the sun, of course, a little bit below the horizon at this point, but pretty much along that same line. So that's our planet news in the west. And then if we head out more toward the east, we can see, well, here comes Orion that Caitlin told us about, and Mars is toward the east, fairly bright. It's just past its opposition when it was directly opposite from us to the sun and lit up very strongly. And also at a time when it was relatively closer to the Earth than other times. It's about a 2-year cycle for Mars, about 27 months actually. So we can see that there in the sky, and it's just above Taurus the Bull. And then there's Orion now stepping into the sky at this time of year, pretty low, starting out the evening, pretty low to the horizon. If you watch through the evening as the Earth turns, of course, that will get higher and higher and higher. Heading back a little bit to the west. Now, in the west, yeah, we're not seeing too much because it's still a little bit brighter in the west. If we probably have to advance our time a little bit to see it, to have it a little bit darker. So, we're going to talk more about Venus. If you want right now, if you want to see Venus, you do have to get out there pretty soon after the time of sunset. And Venus is so bright, it will show up even in a sky that still looks like it's blue. Let's go ahead, and so by the time we get to about 6:30, Venus has set for now, and we can get a better view out here towards the western sky, and probably maybe you might lower in the western sky. There is Cygnus the Swan with the bright star Deneb, and just below it there's Vega that we mentioned as a bright star. And yeah, it's interesting, that question brought up interesting point. And sometimes as we talk about it, those of us who are very familiar with the night sky, we talk about things and we say things in certain ways, and it's great. And really, we really appreciate and encourage anyone to ask questions and pop them in the chat, and they will be, we'll bring them right up. The idea of the brightest star, and that's a real, because what is the brightest star we can see right now? Well, guess what? Here's Orion. If we follow the belt, guess what? Sirius hasn't come up. It hasn't come up yet, right? So what is the brightest star we can see right now? Technically it's not really Sirius, but in another hour it will be, right? So, but the idea, Sirius is overall the brightest star in the sky. Maybe there's times of the year you can't see it, but it is the brightest star in the sky. There's not that many times you can't see it, because, for example, late summer, you can see these stars in the sky. You probably have to, it's early in the morning, okay? 4 in the morning, but you can see them. So there's a lot of catches, and there's a lot of qualifications you have to make if you talk about the brightest star you can see. Okay, but Sirius is the brightest star that there is, whether you can see it or not. Okay, so and just to maybe for the sake of completeness, if we look toward the northern sky, we can find the Big Dipper kind of low, right? There it is. And actually at this point, we're even missing the one star at the end of the bowl, at the handle, I mean, is just not quite above the horizon by 6:30. And there's the bowl, there's most of the handle anyway. And then if we follow up along, next brightest star that you get to from following these two at the edge of the bowl, the next brightest star you get to is the North Star Polaris. And very dimly, there's a handle and then a bowl where the water would be right in there. But it's the Little Dipper is much, much dimmer than the Big Dipper. And if you've got light pollution around you, if you've got a lot of lights and so on, it's really, really hard to see that. And actually, how well you can see the Little Dipper is often used as an indication of what your light pollution is. Okay, so there's a brief tour, and I think also coming up, let's see, is that actually, no, okay, up, all right, so this is Procyon here. This is the little dog. And Procyon, its name means before the dog. And this is showing us exactly why it gets that name, because Procyon has risen before the dog star Sirius is rising. Okay, so Procyon is before the dog. Also, if we go to Orion again and head off to the left, we get to the two stars of Gemini. So this is we're getting really our bright winter constellations are coming into view now. Okay, so as I mentioned, we'll look a lot at Venus, since it's come back into the sky. So right now, as I mentioned, by 6:30 now, it has set. But let's go ahead and take a look now at how that's going to change over the months. And then I'm going to give you another view from sort of out in the solar system. And really, so this is a little bit about understanding how we're viewing Jupiter, what we see, when we see it, and why we see that. And then I'm going to want to connect that back to a little bit of some of the interpretations of Venus over the ages. Okay, so here we are on the 10th. Before I do that, you know what? I forgot one thing I do want to mention. If we go to, I think it's the 27th. There we go. There's the maybe even the 23rd. And let's go a little earlier in the evening. Okay, so as we see, I'm going to come to 6 o'clock. There's a little bit of brightness in the sky still, but we've got a crescent moon and we've got Venus and Saturn right near each other. So that might be a fun thing to look for. You're going to have a pretty decent western horizon. That might be an interesting thing to look for on the 23rd. I think, let's see. So it looks like, yeah, on the 22nd, Venus and Saturn are very close to each other. No, they're not on top of each other, because the things in the sky don't look like large blobs like this. This is what happens in simulations. Bright things get to be big in simulations, but they're all pretty small. So they're not really on top of each other, but they're really darn close that day. But on the 22nd and on the 23rd, now we have the moon coming into view. Okay, so that could be a fun thing. That could be a fun thing to look for. So now let's go back to the 10th. And there, okay, so there we go. Now it's 5 o'clock. It's still kind of bright, but there's Venus above the horizon. Let's get back to get a little bit darker at about 5:30. And let's go see what happens in a month. So in February, look at how Venus has gotten higher in the sky at 5:30 in the afternoon. Also, however, look at how brighter it is at 5:30 afternoon on February 10th, right? As the days are getting longer, the sun is setting later and later. So, on February 10th, you might not be able to see it very well, but it is higher in the sky than it was, and you might have to wait. I believe next February Venus will still be up by 6:30. Okay, so actually, I think we're going to need to leave it at 6:30, and let's see what happens in March. Okay, again, see March, it's gotten higher in the sky. Jupiter, by the way, has gotten lower and lower in the sky. At some point, they cross each other, February or March. They actually will get pretty near to each other as well a little later this year. So Venus is yet a little higher in the sky, but the sky's getting brighter again because it's March and sunset keeps getting later and later. And if we move to April, it's going to be really dramatic. Okay, by April the sun is still up at 6:30. So we've got to try to move to 7:30, but even so, even by 7:30, look at how high Venus is, right? So it's still pretty well up there. We go to May, and again, the sun hasn't set by 7:30, so we're going to have to go to 8:30. There's Venus pretty well, still pretty far up there. Same thing for June. It's the sun is just setting at 8:30. It's Venus is maybe looking kind of dim in the sky and maybe looking a little bit lower now. And when we go and look at what happened between June and July, right? Let's go back. There's June and there's July, same time of day, and Venus has like dropped, right? It's just dropped out of the sky, and by August, it's pretty well gone. It might be just below the horizon. See if we back up, but yeah, then if we back up, we can't see it. So it's well below the horizon now, and sort of in line with the sun. And we can, as we see in August, we'll get a little bit of a view of Mercury, and by that time, Mars will be sort of ending its tour of the night sky, so to speak. So we saw is that Venus kind of got, as we look at the same or a similar time of day, about an hour after sun goes down, we saw that first Venus gets higher and higher, sort of getting away from the sun, so to speak, and then it just gets lower and lower again. And then what'll happen after August is then we're going to see it in the morning sky, and it'll get higher and higher, further away from the sun, and then get closer again. Okay, so that's our earthbound view of what we see. Now let's bring out a different program. And Celestia is also a free program. And by the way, on both of these programs that are free, these are very popular programs. But do make sure that if you do download it, that you are going to either the Stellarium site or the Celestia site. If you randomly search for these things, you'll probably find plenty of places offering it to you to download, but they have probably doctored it up with a lot of malware. So get it right make sure you're getting it right from the source. What Celestia does, Stellarium is pretty much an Earth-based software. Actually, I believe you can put yourself on other planets as well and look at what their sky looks like. But the idea is you're standing on a planet and you're looking up into the sky, and Stellarium shows you what you're seeing. Celestia lets you fly around, and shows you what you're seeing. So what I've done here in Celestia I've just taken us straight up from the North Pole of the Earth until we've gotten high enough so that we can see all of the inner planets, actually, and also Mars, which is an outer planet. And what I just described to you for Venus also pretty much happens for Mercury, because these are the planets that are closer to the sun than us. They're called the inferior planets. The thing with Mercury is, now we saw for Venus that cycle took what, from January until August, roughly, right? Mercury completes those cycles of coming up and getting high and then going down again and going to the morning, coming back up. Mercury completes those cycles much more quickly because it's orbiting its closest and orbiting much more quickly. And that gives Mercury its classical interpretation as something speedy, okay, among other things. So here we are looking at the Earth, or there's the Earth, Mercury, and Venus. And this is set for today, and I do apologize. I doubt that you can read the date and time. They're very small, and also it looks like I'm looking on the feed, and it looks like I'm in the way of reading them on the feed, and I can't control that. I'm sorry. So what I'd like to do is now point out, so this is set for today, okay? So this is what it would, if you actually got into space, flew up over the North Pole high enough and looked down and you could see all the planets and the orbit lines, this is what you would see. So what I'd like to do is just point out how what we're seeing basically. And what we're seeing is we have to think about let's make a line from the Earth to the sun, and then another line from the Earth to Venus. And so this is the idea that our line of sight from Earth to Venus is offset from our line of sight from Earth to the sun. And we see Venus as now above the sun in the evening sky. And I'm just going to kind of mark that distance, and I'm going to save that off to the side. Okay, so that was the distance. That's what it looked like in January. Okay, and then let's go ahead. Celestia lets you run through time. So we'll set everything. Whoops. We'll set everything in motion. And I can make it run 10 times faster, but that's going to be too fast. So we're going to, let's see, we're just about to the end of January. And
Kevin, can I
yes,
jump
go ahead.
in
Yes.
and ask you a question here?
Yes.
So this is not the actual shape of these orbits, though,
Pretty much.
right? These all look like circles.
The orbits, the Earth's orbit is almost, the Earth's orbit is almost a circle.
It is? Oh.
It is elliptical, okay? It is elliptical. Yes, they are elliptical, but sometimes not as much as others. Mercury, I think if you look at Mercury, right? And hey, all right, we can do this. Okay, so there's to Mercury's orbit, there's the sort of short distance. There's the long distance. And we can see, right, that at some points it's further than others, that it is an elliptical orbit. And Mars, I think, it also shows up. Yeah, so the Earth is enough to make a difference. Okay, so even this amount, does make some difference, although the primary difference in our seasons is caused by the tilt of the axis and not the distance, to the sun. Okay, so let's see.
Thank you,
Yes,
Kevin.
you are welcome. We've gotten into February. Okay. All right, so let's let that go just a little bit more. Okay, I just put us into April. Okay, so we've orbited, we're into April now. And now let's go ahead and do that again. Let's take a look. There's the Earth. Okay, so we go Earth to the Sun. We'll go Earth to Venus. Okay, and I think we'll see that that gets a little bit bigger anyway, right? That distance is a little bit bigger. Can I get that now? I can't get that moved over. I might have missed the greatest. Looks like they're about the same still, actually. Okay, and I might have missed the greatest. And basically, it will get larger. And then let's erase. Okay, and then let's just have to carefully speed things up. So, all right, we're so into April. So we're into May, June. Let's get it. Okay, so there we are. So now we made it to July. Okay, and see where the Earth is and see where Venus is, right? So now if we check that out in July, and I see my problem too. I really should be measuring it this way, right? Okay, the apparent distance between Venus and the Earth has gotten much, much shorter. Okay, and that's really, I shouldn't be measuring it that way. I should be measuring it that way. Okay, so that has become much, much shorter. And at some point, look at what's going to happen, right? At some point soon after that, this is early July. At some point, okay, I see August 9th, and it looks like you take the Earth, Venus, and the Sun, they're about lined up. So in other words, Venus, this is a point that's called inferior conjunction, roughly anyway. Inferior conjunction, I don't think we're not quite there. We're not quite on the same line, but we're pretty darn close. And Venus is now in exactly the same direction as the Sun, and we don't get to see it. So it's left our evening sky, and then it will eventually now reappear in the morning sky. So this behavior of the inferior planets is actually their official designation. The ones interior to us to the Sun from us. This is what gives that appearance of cycles of what we see in the night sky. Interestingly enough, Venus will complete 5 of these cycles every 8 Earth years. So in other words, Jean, thank you. So Jean is listing in the chat the magnitudes of the stars, so the brightness, and the magnitude system was devised to compare brightness of stars. And the one thing that you have to remember and understand is that they started with that the smaller the number, the brighter the star. And I think they started with like 1 being a bright star, and going to 6 is about the dimmest star that you can see in good conditions without light pollution. But then it turned out some of them were brighter, so that Sirius is actually a negative number. Canopus, which I think is southern hemisphere, right? We're not going to see that one, also negative number. Um, Arcturus also. Um, Thank you, Gene. Yes, okay. Arcturus also negative number. So Vega is slightly positive. So there's and Gene, are those the whatever 10 or so brightest? How many you have there? 7, 8 stars. Um, so so when we say Sirius is the brightest star, this is what we mean. You're not going to find a star that has a brighter brightness number, which is more negative than Sirius. And then you can see Vega's up there pretty bright, and Arcturus, right? So Arcturus is up there pretty bright as well. So thanks, Gene, for that very, very much. Gene's a member of the stars as well. And, so again, this just shows you, just this club has a lot of people who are very, very into and passionate and knowledgeable about this topic. And if you'd like to learn more, boy, that's the place to be. Okay.
And I
yes,
just, Kevin, as a
go ahead.
plug for Stars Club, I'll
Mhm.
say you don't have to be the most knowledgeable. Even just bringing the enthusiasm is also acceptable.
With that, I think
Go ahead.
the only requirement is that you really like being out there at night. You love being out there at night and looking at stuff, and maybe you'd like to learn more. That's all it takes. And then maybe as you learn more, maybe you'd like to share that with others as well. But yeah, that's all. There's no test. It just come on down. Okay. I think you'd like it a lot. Okay, so that's again that's sort of that interior motion. This is why we see what we do with the Venus getting higher and further away from the sun, easier to see. It stays up later in the evening, and then it just goes down again. Let's come back now. We'll just come back to the night sky anyway here from the stellarium. Nope, that was Celestia again. Sorry, the stellarium view. There we go. Oh, I got to get rid of those lines. Okay, there we go. Alrighty, and and we'll come back to tonight. So Venus, then we think of Venus. The interpretations of Venus classically, we inherit so much and focus so much and maybe too much on the Greek interpretations of things. And Venus being so bright and beautiful was, considered to be a goddess of beauty and love and so on. But in other cultures, Venus was a lot more than that. We trace a lot of our star watching back to the ancient Sumerian civilization that arose in the Middle East about roughly 4,000 years before the Common Era, not too much before the Egyptian civilization, the pyramid building civilization, arose at about the same time. And we do trace a lot back to the Sumerians who were looking at the sky. They called Venus Inanna, and it was also a female deity. And but she was more than also sort of beauty and fertility, but also sort of a war goddess as well. And that tradition picked up, the Babylonian civilizations kind of picked up in the same area of the world, and they pretty much inherited the Sumerian interpretations. They viewed the Sumerian writings as sort of sacred texts. They called Venus Ishtar, and very, very similar. you get to the Greeks and Romans, they kind of dropped the warrior thing and some of the other interpretations and just kind of kept with the beauty. And then you get over here to South and Central America, and you have the Aztecs and the Mayas, especially the Mayans. And the Mayans tracked Venus to incredible accuracy. And they knew, I mentioned this idea of Venus completing 8 of these cycles in, sorry, 5 of these cycles in 8 years. And let's see how good that is. Wrong thing. Okay, there we go. So let's see how good. First of all, okay, we're gonna have to come back. This is tonight, so we're gonna have to come back earlier in the evening. There's Venus, and let's go to February where we can get it a little bit later in the evening, maybe. Okay, so there it is. I guess there's no major stars that it's next to speak of. But now let's set this to 2031. Let's see what happens. There it is. It popped into 2031. So you notice there was barely a change, right? Let's go back to, there's 20, here comes 2023. Okay, there's 2023. We have Jupiter in the sky at the same time, but watch these 2 stars, watch that star, and we get to 2031. There's that star, there's those 2 stars. Venus is in virtually the same place. I believe the cycle is maybe about 2 days off. Okay, so that Venus will be at the same place, same time of day, among the same stars in 8 years. Now, it'll be there before 8 years. Okay, it actually has been there 5 times between now and 2031, but not at this time of night. Okay, it might have been among other stars, those other stars at other times of night. So the Mayans knew this very, very well, and with and their interpretation, I believe it was a male deity, and very, very much warlike. But the other interpretation that the Sumerians had, that the Babylonians, and then over here to the Mayans and the Aztecs, was also a connection to the other underworld. Because what did we see Venus doing between June and August, right? It sank, right? It went down to the underworld, right? And disappeared from the night view. And it was gone, it's gone for a while, and then it comes back in the morning. And this disappearance in those civilizations I mentioned, there is this connection to the underworld with Venus. And again, that was more or less dropped by the Greeks and Romans. However, Mercury also, as another inferior planet, officially, also has a strong connection, and that was kept by the Romans and Greeks, among other interpretations of Mercury. But so there's the things we see, and a lot of what we names of planets, interpretations, and stars and constellations as well. A lot of it has to do with what people were seeing, and as they were very, very carefully and meticulously watching the sky, because for those people in those times, this was their best calendar and guide to the coming and going of the seasons. How are we doing? I see there's
Kevin,
some activity.
I was just gonna
Yes.
let you know that we only have a couple minutes left.
Okay, thank you. Okay, yes, okay, yes, we do. I think it's more like 1 minute. So how have we wrapped up what's in? And you know, I notice I'm looking over here. What Jean gave us was in the question and answer. I hope everybody can see that.
Marguerite pointed out, Marguerite originally said that they couldn't see it, but then she said that there's the Q&A everyone option. So I'm not sure what happened there.
Okay,
But maybe that's information that we could share again next month in the
okay,
chat.
okay,
Okay.
yeah,
And we
yeah,
do have one question for
yes,
you, Kevin.
okay,
It's actually from Caitlin. It says,
okay.
throughout history, who was the group that kept the best records of the stars?
Oh boy, wow. The Sumerians were really good. Okay, they were really, really good, and their observations were used subsequently by the Babylonians. Babylonian astronomy is really Sumerian astronomy, but then again, the Maya, especially with Venus. Wow, they were, and then they had that calendar, you know, that has these cycles of 20 within 60 or something like that. And I apologize, I didn't know I was going to talk about it, so I didn't refresh my memory on it. Um, that they also had really, really good records, and I'm not sure I could say who was better. Okay, so folks, thanks to everyone for joining us today. Thank you for all your questions and other contributions in the chat and Q&A. Now, coming up at the end of the month, or near the end of the month, on the fourth Tuesday, will be our Stars Club. The Stars Club will have their meeting, and then early in February, on the first Friday, believe that turns out to be the third next month, will be Stars over Springfield.
Kevin, just a
Yes.
reminder that Stars Club for January and February meetings, that's both Zoom.
That's right. Okay, so they're both Zoom, and as I mentioned at the start, if you are interested in that, maybe Jenny, maybe pop Rich's email into the
Yep,
chat
typing it right now.
really quickly one last time. And so if you're not,
Oh, I'm sorry, that's not right. Excuse me, everyone.
yeah, no, that is not right. It's at Yahoo.
Oh,
Yeah, it's actually not right in more than one way. Okay,
I'm sorry. Yeah, I
that's
thought
all right.
that he was using Gmail now.
You know what? Maybe he is as well. Okay, that
Okay.
could be. But I believe
Okay.
it should be, yeah, 31416. There
It's
you go.
314. Yeah.
It's the first few digits of pi. So get an email to if you're not in Stars already, get an email to Rich. He'll get you, and then he'll put you on the list to get that link to the Zoom meetings for January and February. And then also soon after that meeting will be Stars over Springfield. That is here at the museum in person live, and we hope to see you at that as well. So Jenny, unless you have anything else, I think we'll wrap it up. Thanks to everyone for coming by.
I'm just adding my email address.
All right.
Yep, all set.
Okay, very super. So definitely you can contact her. And also I'll just give you another one, planetarium at springfieldmuseums.com. Okay, that's easier than my name. And that's another way you can contact us about things astronomical. Okay, so thanks to everybody for coming by. Have a great, safe, and healthy month, and get out there and see some cool stuff in the sky.